bring up and check out. We're going to burn through these quick because we all did it back in that back room. I will say, this is another one of my favorite slides. Don't be this guy. Don't install the regulator and say, oh, it's all good, bye. And they'll also tell you, and I really don't understand why this is. I cannot tell you a number of times we've gotten calls. Oh, I need help bringing this regulator up. Yeah, we've been working on this boat for 2 months and the customer is leaving for Bermuda on Friday. It's like, I don't know why, the alternator regulator is always the last thing that gets looked at. But don't be this guy that just says, hey, it looks good to me. Do instead first run tools, simple assessments, LED patterns. Look at the pattern. What is the LED doing? What is its blinking pattern? You can see the definitions in the guide. And as you can tell, don't memorize them, look them up, because even I get them wrong. Look at the other instruments that are in there. Does it match? Does it seem reasonable? Look at the displays. Use your ears. Did you hear the engine loading up? Use voltmeters. Use clamp-on amp meters. There's a ton of stuff you can do with just simple tools without getting really over the top. If you then go into the level using the Wakespeed app, that's your next tier. You go use, like we did, the monitor page, the log page. You can ask customers to take logs, have them email it to you. These are all tools available to you. My suggestion is start simple. Look at the LED, look at the volts, put a meter on the blue field wire, see if you're getting field dry. If you don't, just start real simple and then move up the food chain. Okay? Two-step approach. This is exactly what we did back there. Engine off, we connected up the app, we went to the monitor tab, we made sure that we were getting the voltages measured and the current measured, and we found out that we had the system wired wrong. So we adjusted the system wiring. We moved the load onto the side of the shunt so the shunt could see all of the load, not just the charging aspect. All right. Next step is you want to turn it on. Again, let it warm up, use the monitor tab, watch stuff rise. You should see voltage and current rise. You should see the alternator temperature come up. That's your next step. It's also during this engine off time. This is a great time if you've got things like a Victron servo. It's a great time to check to make sure that the Wakespeed's communicating with it. If you have a NEMA 2000 display, great time to make sure it's communicating. Remember, when you plug in to this USB port, you power the logic side. You don't have to turn the engine on. You power the logic side. It's a great way to check out all the logic aspects of the regulator and unplug the USB before starting the engine. We don't want to shock load it. Okay? The expected behavior is like we saw there. It starts out so slowly blinking, starts ramping up. You'll hear the engine loading. You'll see voltage come up. You'll also see if you've got a slave mode. We've talked about all this stuff. I'm just kind of summarizing it. You'll see that color shift. That's something you definitely want to be seeing. Hint, start out with a battery that's at like 60 or 70% state of charge. Give it something to do. If you want to start out with a full battery like we had back there, just know it's going to quickly go into float mode because the battery's full, right? Listen and watch. You don't need anything more than your eyes and your ears and a couple of gauges. You should hear the engine loading. You should see delivery of energy on your monitors. Really, that's a lot of what you really need to look at. You can do this all with or without the Wakespeed app, right? Some problems, there's no LED. Check the power wires. Is it installed? Most of the time it's because people these are the two critical wires. It doesn't take much to get this regulator to blink. You can make it blink by USB power or the brown wire with the black and the yellow stripe wire are the two critical ones. Remember, the stripe wires are the ones that go to the logic side of the regulator. So this is the logic ground wire. So you need the brown wire for power, you need this for ground. That's all you need to make this thing power. We've had customers call in and says it doesn't work. They haven't hooked up all the wires. So that's the thing you want to do. If you're getting red LED, there's going to be two causes for it. The first cause is that the regulator is in a fault mode. And that is because, I'm going to force this regulator to go into fault mode. By the way, I will tell you, because I know you're all tired, if you go to the Wakespeed website and you go to the Learn tab, you will see videos on how to do all this stuff. Okay, so that regulator is starting up, is doing its blinking green. After about 30 seconds, you're going to find it goes into a fault. And the fault is that it can't see battery voltage. And the pattern you're going to see are 2 bursts of quick blinks, and then it's going to blink out the fault number. It's a 2-digit number. Don't count the bursts. When we get a support call that says, I have a fault 44, it's like you are definitely an overachiever because you're counting bursts. Don't count the bursts. I'm not that cruel of a person. So it hasn't quite made it there, but it'll get there eventually. What's that?
It just did the burst.
Oh, did it? Oh, okay.
So now we're getting error 14.
Okay. If you look up in the documentation, you'll find fault 14 says no battery voltage has been sensed. So that's an example of a fault. Okay. The other time that you'll get red blinking, and that's a very distinctive pattern. The other time you'll get red blinking is if one of those required sensors are not present and the regulator is running in a degraded mode. You'll get the normal blinking pattern, but it'll be red. So if the temperature sensor is missing on the alternator, we're running in half power mode, you'll see the normal pattern, but it'll be blinking in red. That's the second time you'll see the regulator blinking in red for a color. First run problems, the alternator. By and large, this may seem like a cheeky answer, no output from the alternator. Should there be? You'd be surprised how many times we get support calls that says, I'm getting no output from the alternator. Well, the answer is there shouldn't be, because you're in New England with lithium batteries, and it's -20 out, and you can't charge batteries. Or the BMS is asking for no charge. There may be a legitimate reason why there's no output from the alternator. You can sometimes tell that with a blinking pattern, or you can look on the Wakespeed app, or if you have a servo, the servo will actually tell you that monitor tab that we had. It'll tell you what mode the regulator is in. It'll tell you what the field drive percentage is. If you find the field drive percentage is 0, either through the servo, VRM, or the Wakespeed app, then the Wakespeed has been told it shouldn't be driving the alternator. Now, on the other hand, if you find that there's a number there, it's trying to drive at 30 or 40%, we have another issue. But surprisingly, this comes back to customer education. This right here is surprisingly a fairly significant number of calls. No alternating output. Field alternator okay. We actually talked quite a bit about this. You can use a voltmeter on the Wakespeed, and you can watch as the percentage drive goes up. You should see the field voltage go up in a controlled way. I will tell you that you have to have something connected to the field wire. Just the characteristics of our electronics. If you have just an empty wire like this, you'll get random information. You can put a resistor or a light bulb if you have an old school light bulb. Just put some sort of load on here, and you should see the voltage coming up. And there should be a direct correlation between what that field drive percentage is and the voltage you see in a controlled way. It's a great way for first checkout. You can clamp an ammeter like we did in there on the output of the alternator, put a voltmeter on the battery, and or put a voltmeter on the field wire, and as we go from the lazy warm-up into the ramp phase, you'll see that stuff come up in a controlled way. Expect to see engine off. Measure the field ohms. We did this yesterday. We also tried talking about that screw, the magnet pull on the pulley. If you want to do a full field, you can do this while the engine's running. Disconnect the Wakespeed. Sometimes the first thing is do a divide and conquer. Disconnect the Wakespeed from the alternator itself. Take the field wire off the alternator and briefly touch it to full field. See that magnetic pull, or if the engine's running, you can hear the engine load up because you're basically stomping your foot on the alternator gas. These are techniques you can use. Be very careful. Be safe here, okay? Any questions on this? Comments, Rick? Got that? Spinning rust guy?
No, you've done a great job.
Okay. All right. First run, alternator's only putting out a few amps. These are problems we heard, first run problems. I'm only getting a few amps out. Well, is the battery full? Look at the LED. Are we in float mode? Are we in slave mode? And is the BMS asking for a small number of amps, right? Alternator overheating. These are another reason when we get low output from the alternator. Alternator damage, that's actually is a reason, and typically when the diodes go bad, they'll usually all go bad, but I have seen them where like only part of them go bad, so you get maybe 20 amps out of the alternator just because part of it's working and not the whole thing. So there are some esoteric ways. That's where you can do that full field test, or pull the alternator and take it to a competent shop and have it tested.
Yeah, if you do a full field test and that alternator comes up really slowly, then you know it's an alternator problem. It just needs to be fixed.
Yeah. Our experience, alternators are tough. It's pretty rare they're bad. When they are bad, the most common reason is the diodes have gone out, and so usually a result of low quality diodes and or extreme overheating on the alternator. That magnet screwdriver test won't tell you that. That full field test will. You should hear the engine load up. I mean, literally, you just put it on for 2 seconds and you should hear the engine struggle if the alternator diodes are good. If they're bad, you won't hear it struggling. So, but in general, alternators are pretty tough. They do have diode packs go out though, and that's ways to test it. Oh, this is an interesting aspect. Alternator output unstable. The most common reason we see that is because the alternator gets hot. You remember I told you how we do regulation, active regulation of the alternator temperature? If the Wakespeed is not able to actually regulate it, if it's too extreme, we go to the next step, where like everyone else does large pullbacks. And you'll see that in the behavior. You'll see like a 5 or a 10-second period where the alternator does really hard output, and then output will go way low and go real hot and way low. This is where the log file helps. Look at the log file. You can see the alternator temperature. You can see it reaching its limit and going over its limit. You can see the field drive being cut way back. That log file will tell you over time what's happening. That's how you can know what's going on. The solution to that is derate those percentages, that normal percentage or the half power, that 100% or the 90%, cut that back to a smaller number. Because what it's saying is that alternator is not capable in that install of being driven that hard. So give the Wakespeed a little bit of help. When we're under temperature, don't let us put the gas all the way to the floor. Let us just kind of manage the gas a bit. So that's, if you see that kind of temperature cycling, improve your cooling on your alternator and or reduce the derate factors is the way to solve that. CAN issues, the other place I've seen with instability is with the zero output technology, or if anytime we're actively regulating current. And it's usually from getting battery current via the CAN. We're trying to do process control over the CAN, and sometimes we get instability. If that's happening, you'll see cycling going on, and again, the log file will tell you, because you'll see a target value for the amps, but you'll see the amps going significantly over it and then get cut back. It's just, we're just not getting enough responsiveness. The answer for that is to hook up the gray and purple wires and let the Wakespeed regulator sense the battery current information directly. When it comes over the CAN, best case, we get that information twice a second. When we sense it directly, we're getting it hundreds of times a second. So you can kind of see the difference in the challenge. There's something also called slow ramp. This is kind of a real obscure feature. When we are very far away from a goal, we'll ramp the alternator up quick, and as we get close to it, we'll kind of sneak up on the goal. We call that fast ramp. Sometimes in some environments, the system overshoots and you get instability on voltage or current. A way you can try is to enable slow ramp, and the way you do that, its subtlety, is in the app you'll toggle a toggle, but with the, if you're doing it manually, you use a negative number on the engine warm-up delay. And what that will do is have the regulator just always come up slow. When we were back in the marine world, we had slow ramp. We added fast ramp because we had guys in RVs driving in the city, going stoplight to stoplight, and going one block wasn't enough time to ramp the alternator up. They weren't getting any output, so they wanted a fast ramp. But that's another really obscure. I can only think of one vessel where they've had to actually do that. And I'm not really sure it was a real problem, but it's a very, very intelligent guy I've worked with for a very, very long time. And he said, yeah, that fixed my problem. So I was like, cool. Common issues, incomplete install, only connected a few wires, testing it out, overthinking the configuration, going into expert mode. When I get customers, I step way back. I have a belief, start simple and get success and work from success. If you want to add all these advanced features, great. Let's have a very simple configuration first and make it work, and then we can start layering in the advanced features. Very often, people will just dive into the deep end first and create issues. So that's overthinking the stuff. The 15 amp fuse, you'd be amazing how many calls we used to get because that 15 amp fuse on the red wire wasn't installed. So many, in fact, that actually the version 2 of the regulator, if it doesn't see a voltage on that red wire, it'll throw a fault. But if you got a version 1, we don't sense that, and that's a good reason why the Wakespeed ain't going to drive the alternator. No power. Or they reversed the 15 amp and the 3 amp fuse. They put the fuses in, but they reversed them, and the moment they started to drive the alternator, that 3 amp fuse opened because it just wasn't up to it. We've talked about issues, common issues with alternators. I think the biggest issue I've ever seen is this converting of alternators. We've talked about this quite a few times. It can be done well, but it can oftentimes not be done well. Some alternators are good for it. There's a lot of them. It's not that they're bad alternators. It's just they weren't designed for this heavy power generation to recharge house batteries. They were designed to put a little bit of power in the starter battery and run your radio and your fans. So that's another common area we've found issues. You anything else on the alternators, Rick? Okay. On some very specific installs, the #1 issue we have with Lynx BMS is that white wire. If you look at the wiring details from Victron, there's a ton of jumpers and a ton of things, and you have to get it exactly right. I will also tell you there are Victron diagrams out there that are wrong. Some of their first diagrams were wrong because I've had Victron dealers send me the diagram and it doesn't match what's on the website. So they have a down-rev version. Go to the website, get the latest drawing. Victron on the Lynx BMS has got 2 or 3 drawings on how to wire up the Wakespeed. There's one on the back of the wall right there. That white wire is the single biggest issue. A very quick test is, because what happens is the regulator won't go anywhere without that wire being enabled. It's held in standby mode. A very quick test is just temporarily connect this white wire to positive battery voltage. If things start working, then you know this is the issue. And it's usually the little jumpers on the Victron. You also need to know on the Victron Lynx, you have to go in and declare that we're talking to an alternator. There's some auxiliary circuits that you have to declare that's being used with an alternator. That's part of the setup of the Lynx. So make sure you do that. RJ45 jacks, different pinouts. Boy, have we talked about that in the fun. So go to the Wakespeed website, the Learn tab. There's a Victron install user's guide. It talks about the pinouts and how to make a crossover cable. Buy one of our crossover cables if it works. Make your own. It doesn't matter, but that's a very common issue. Not very common, but it's probably the most common issue that we have when people are doing MG Energy or REC BMS. REC also, by the way, their default cables will be Victron. You have to get a Wakespeed variant or you have to somehow do a crossover. Okay, CAN issues, we've talked about this. Terminators, probably the biggest thing. I think the second biggest thing is that they just haven't hooked up the wires or they crimp things wrong or they've gotten overcomplicated in their system. They've gone from one style of backbone to another. Keep it simple, right? Lithionics, a very specific detail. You remember how I told you we can do BMS aggregation? With the Lithionics batteries, you have to manually configure each battery with the new instance. They won't automatically do it. So if you install 2 batteries, you have to go to that second battery, and there's instructions from Lithionics to use their app to configure that battery to say it's the second battery. If you don't do it, the Wakespeed's going to think there's 1 battery. And by the way, all the Lithionics gauges are going to think there's 1 battery. So if you got 2 320 amp hour batteries, the Lithionics is going to say, hey, you have a 320 amp hour system. That's your first clue. When we're delivering energy out, if the alternator is producing 200 amps, but that little Lithionics gauge says 100, because 100 is going to each battery, that's your clue. Everyone thinks there's only 1 battery. So you have to reconfigure the Lithionics battery, specifically be a second battery, and a third and a fourth, okay? Over time, yeah, this is a great one. The service switch. We have had alternator fail. We've talked a little bit about load dumps and the dangers associated with it, right? You get that massive voltage spike, and the avalanche diodes will suppress that. Well, what will happen over time is the avalanche diodes will eventually say, I've had enough. They're good for about 200 to 300 hits, something like that. We had one, I had a call from one installer. They said the person brought their van in because their alternator was smoking. And actually, while it was in, they said, oh Lord, the thing just caught on fire. Horrible thing, you never want to hear it. Here's what had been done. They had installed the system correctly. We recognized, what had happened is the operator had read on a forum somewhere that if you're using your van to drive and get groceries and Slurpees, turn your battery off. Disconnect your lithium battery. Don't stress it. You know, it's not bad advice. Maybe that's not a bad idea. There's no reason to charge and discharge when you're just getting the Slurpee, right? The problem was the way the system was configured is they turned the battery off, but it didn't turn the alternator off. So every time they started the van, the Wakespeed woke up. There was sufficient residual magnetism in the alternator to have it self-start. It would start ramping up. There was no load because the battery is disconnected. It would go up, hit the avalanche diodes. Wakespeed would do a load dump trigger, and we would shut everything down. Everything was safe. It happened every time they started the van. And after 200 or 300 times of starting the van, the alternator gave up the ghost. They aren't meant for that. The solution is, don't open that service disconnect switch. Hide it somewhere. Another thing you can do, and I know this is very common in the marine industry, you can get those service switches with auxiliary contacts, little smaller ones. Route the brown wire. Where's my brown wire? Route the brown wire through that service disconnect switch so that when the battery is disconnected, the regulator will also be depowered. That's actually a good solution for that approach as well. But these are the dangers of these newer systems that have to be thought through. Hadn't been thought through what happens if the customer does that. Yeah, I don't know what XXX is. That must mean I ran out of time. Danger zones. All right. I guarantee you we're getting to the end here. This is just kind of revamping things. More hat than saddle. Other charge sources not configured correctly. You know, just because the Wakespeed is backing off, it might not be the Wakespeed issue. You may have solar panel chargers that are overstressing the battery and initiating a disconnect. Alternators without surge suppression. I'll make a little comment. This technology does not exist for 48 volts. The whole transportation industry hasn't solved this issue for 48 volts yet. As a matter of fact, for 12 and 24 volts, the ISO standards say avalanche diodes is the best protection. For 48 volts, there is a standard. It simply says, thou shalt never have more than 68 volts, I think is what they say. You have to design your system to prevent overvoltage, which is what we do with our batteries that we have a good integration with. So just as it's not important now, but as you move forward, just know that's not a thing today. Some people are working on it, but it's not a thing today. Existing alternators, we talked about, be leery of battery systems not designed as a system, people just buying components off the shelf and throwing it together. Battery switches, web foreman experts. Yay. Load dumps. I was waiting to find this because this is one of my favorite topics. Everyone down in Reno hates the phrase load dump because this is my favorite topic. Who in here knows what a load dump is? Oh, I am disappointed because the guys in the back either aren't listening or I'm disappointed. A load dump is defined as an event where an alternator is active and the battery is disconnected. It was discovered right there. That is the definition of a load dump. Right? It was discovered back in the day when we went from generators to alternators. And mostly it came about because of corroded battery cables. You'd go over a railroad track and you'd get a little bit of disconnect and the alternator is active and we don't have the battery to absorb that energy and you get this voltage spike. The engineering reason why is because alternators have a high inductive component. It's called an inductive kick. It's actually how spark plugs work. When you get that 50,000 volts to spark a spark plug, that's an inductive kick. With the alternators, when we see a load dump, that alternator is producing energy and all of a sudden doesn't have any place for it to go. Inductors don't like that. Inductors will rise voltage to try to keep that amperage the same. That's a physical property of inductors. As that voltage rises, the Wakespeed regulator will detect it and very, very quickly, almost immediately, turn off the field drive. However, the damage is already done. There are joules of energy contained inside that alternator because it's a giant inductor and you're going to get a giant voltage spike. So much so that the auto industry realized this was a problem. So they documented it. We love the auto industry. There are millions and millions of dollars poured into this stuff that we can take advantage of. I love it. For a 12-volt system, this is the test curve of a load dump. This comes out of the ISO specs. For a 12-volt system, you expect to see a 100-volt spike. For a 24-volt system, you expect to see a 200-volt spike. Could anybody guess what happens on a vessel when you apply 200 volts to your 24-volt system? I have told you 2 or 3 times what happened in one case. $20,000 of damage and the refrigerator caught on fire. There were 2 problems with that install. Number 1, the batteries were not proofed. They did an uncontrolled disconnect. They weren't ones that we had looked at. It was an unfortunate choice. An uncontrolled disconnect happened, and the alternator they were using did not have avalanche diodes. If either of those 2 conditions hadn't existed, we wouldn't have seen this. But they existed. So we had $20,000 worth of damage and the refrigerator on fire. And I keep harping on that. I don't want to be scary about this. Remember, we've done tens of thousands of these. We usually see about once a year somebody with tears. It's some event. And, you know, that is an extreme case. The more common case is the electronics gives up the ghost, or, you know, maybe they had to replace their AM radio or something like that. It is not a joke. System, system, system. Design your system. This is why guys in Reno hate hearing me harp on this. This is the single number 1 killer and single number 1 risk we have in these high energy systems. We want to prevent this from happening. We want to have batteries and alternator regulators as a system, which we have tested on our Wakespeed labs and are listed on our app. If it's on here, we feel confident this is going to be safe. Install it like we tell you to do it, and you're going to have a good starting point. If it ain't on here, it may be fine. I just don't know. I just don't know. The other thing that the auto industry did when they first discovered this is they said, well, this is unfortunate. Guy drives over railroad tracks and we get this 100-volt spike. Well, I guess all you guys out there are going to have to figure out how to deal with it. And the guy who made the radio said, oh, wait a minute. It's going to cost us 34 cents to deal with this 100-volt spike. We're going to have to put protective devices in there. And the problem is I make radio for GM. They're not going to pay me 34 cents, so I can't do that. Auto manufacturers are cheap. They won't even pay 34 cents. And more so, the real problem, there were more problems. You can't protect light bulbs. You put 100 volts to a 12-volt bulb, guess what's going to happen? So having the individual components survive that 100-volt spike was not really viable. So what the auto industry said, okay, here's what we're going to do. We're going to create a best practice. We're going to have a best practice of suppression. And we feel the best place to do suppression is in the alternator with avalanche diodes. So this ISO spec, oh no, darn. This ISO spec has actually a second curve that clips here. And for a 24-volt system, for a 12-volt system, that's usually around 28 to 32 volts. I think the spec is actually 35 volts or something like that. What it means that as a designer, when I'm designing something to go in a transportation environment, I only have to design my stuff to survive 35 volts. I don't have to design it to survive 100 volts. There are physics and costs. It's actually not hard to design for that. 42 volts is a magic number. It's pretty easy to design for that, okay? And that is the best practice, and that is why I keep harping on avalanche diodes, because way back in the 60s, really smart people said, this is a problem, this is the best way to solve it. Okay. Have I said enough on this topic? Okay. And how do you know if your alternator has avalanche diodes? You ask the alternator manufacturer and you hope you trust them. I will tell you that the partners we work with, if you go and see where to buy, we're pretty confident they have them. There are external suppression devices. Of them all, I personally like the Balmer one, the APD, the best. I don't think it's a replacement for avalanche diodes, but if you want to do belts and suspenders, that would be a way to do it. Yes, sir?
So if you're in the app, in your app, you're in the alternator section, and the alternator you select is on your A party list, is it fair to conclude it has met that bar?
I will tell you that we have very good conversations with a number of alternator manufacturers. I can pick up the phone and I can talk to the engineering team at Nations Alternator. I can pick up the phone and I can talk to the engineering team at American Power Systems. I can pick the phone and, believe it or not, I can talk to the engineering team at Prestolite. So yes, they all do. You want to guess what happens when I pick up the phone and try to talk to the people at Balmer? So, I don't know. I have heard that most of them do, but I've also heard that not all do. And that's one of the reasons they came out with the APD. My answer is go and ask the alternator manufacturer. I personally have a high level of confidence that the big manufacturers, the Leesnavilles, the Prestolites, Decos, not Decos. If it's not Prestolite, it's
Yeah, Prestolite, Leesnaville, most of the DC engineering they're going to have.
yeah. So anyway, I mean, most of the big guys do. I also know for a fact there's ones who don't, and I think we talked about this yesterday. The reason why people don't put avalanche diodes in is they cost more and they're less efficient. You may have heard through the grapevine of a fairly high dollar value vessel that had an issue, large number of batteries. Turns out that didn't have avalanche diodes in it. And that was an unfortunate case. And the thing is, when we went back and talked to the installer, they said, yeah, I know, because the manufacturer used to put them in and got too many service calls. Well, gee, do we know why you get service calls on avalanche diodes? Okay, so the answer is APS, Lease Neville, Nations, yeah, I'll guarantee you they do. Balmar, which we think are great alternators, I believe most of them do, but I think there's one or two who don't.
That verification in your lab is not really your
I don't look at alternators. Yeah, I don't look at the alternators. Yeah. And by the way, the alternator I have on my test bench does not have avalanche diodes. It's a 48 volt 200 amp alternator. That's my primary test bench alternator. I actually use that to test this because I'll drive and force a disconnect, and I want to see. I do this at the very end. I do a lot of testing ahead of time, but the final one is, and the first time I did this, oh my Lord, this guy grabbed a fire extinguisher, literally. He said, don't do that. And I did it anyway because I wanted to prove that the behavior of the system would shut down safely. That's the type of stuff we do so that you guys don't have to. That's how it makes that. Okay, but good question. All right, test switches. We talked about this here, and you've got an example of one over there, right? Is this the one with the aux contacts or not? Okay, perfect. So you can get these. This is actually an AB switch, a rather complex one. But if you look on the back, you'll see there's the heavy power terminals. And then you see these little ones here. These are the field disconnect. You'll see them called field disconnect. These were actually pretty common even back in the day with lead acid batteries. A lot of times you'd run your power wire through that oil pressure switch, then through this guy, and that way when somebody turned the alternator, when you had the batteries turned off for some reason, you wouldn't burn stuff up. So we think this is a really good idea to do. We think a good idea to do is hide that thing away. Don't make it readily available. We think a good thing to do is put a little sticker on it that says for service only. Do not turn this switch off while the van is running, or your hair will fall out, you'll grow fat, your girlfriend will cheat on you, and your dog will bite you. We think having all that kind of stuff, none of that is excessive, okay? Because, well, we want systems that are going to survive despite how creative the operating public is. Alternators, more hat than saddle. Boy, have we covered this a lot, right? Heavy duty, very aware, converted alternators, careful of something with no surge suppression, high voltage diodes. You want to know the worst offenders in this space? And I'm going to say again, when I make these comments, I want you to understand these are not bad products. They're just products that are not appropriate for this use. Okay? There are a class of alternators that are largely sold to the stereo guys. And what they'll do is they'll have a little small frame alternator that can advertise at 320 amps. Well, in that usage model where you're just doing a couple of minutes to try to pull that much area out, they may work very well. Those guys will overheat very quickly if you try to run them for 20, 30 minutes. I'll guarantee those guys do not have avalanche diodes in it. So for that application, they probably work well. They are not a good choice for these high energy systems because they are more hat than saddle in that case, and they don't have the protection. So, unproven batteries. We have a list, and we have engineering to engineering conversations to get on that list, especially with the lithium batteries. And we have examples of those batteries where I can put it on my bench with my giant alternator. And Rick doesn't live near me anymore, so my wife comes out with the fire extinguisher when I do this now, right? So, again, there's a lot of batteries, and there's a growing number of lithium batteries out there. Whether they're drop-in batteries, which, by the way, we do have one drop-in battery that we support, and it is battle-borne. We used to have two. They stopped talking to me, and they actually stopped talking to me before the acquisition, so we actually were leaning toward taking them off. But we have engineered a system with battle-borne to feel safe for 12 and 24 volt deployments, not 48 volt. But for 12 and 24 volts, we believe the approach is appropriate. And part of that is myself having an engineer conversation, who in this case happened to turn out to be our CEO, who knew how these batteries worked. And we could define when the batteries would disconnect and make sure we were safe. But just because a battery is listed as you can use it for anything, or just because a battery has a connection or a CAN connection or a wiggle wire, it doesn't mean it's going to do what we need. And specifically, that whole disconnect is the most important area that we have to focus on because of reasons that we've already covered with the load dump. Be careful about customers who bring batteries in. It always happens. Customers buy batteries and say, make a system that works with this. You all can decide whether you want to be involved in that or not. Deploy proven sign, service disconnect, auxil connector, warning label. You can make one like I said or not, or something a little bit more palatable, but lots of that type of stuff. That is the end of this presentation.
Great.
Thank you very much.